Welcome to saturation curve. I want to show you how to use this curve. It's an important thing and it can tell us so much information by simply taking a few key pieces of information. For example, if I happen to know the temperature outside today, and let's say it's 30 degrees Celsius, and I happen to know how much water is in the environment around me, let's say that it happens to be at, we'll make it about 12 grams per kilogram. I know that given my spot on the line, which is about there, let's change it to dots, given my spot on the line, which is about there, I know that I am at 50% relative humidity. Now this curve is nice because they give me two pieces of information. I have my 100% relative humidity line and I have my 50% relative humidity line, but that 100% humidity line can also be called my saturation specific humidity, or another way of saying is my saturation specific mixing ratio. And actually it's the mixing ratio because if I look out over on this side, I know that my unit is in grams per kilogram, and we've talked about this. But when we see grams per kilogram, what we're referring to is mixing ratio. So everything on this side is actually a mixing ratio when we see that unit. If I saw the unit and it happened to be in meters cubed, if it was grams per meters cubed, then I'd be talking about specific humidity and saturation specific humidity. Either way, this curve gives me a lot of information. Everything on the curve is 100% saturation or saturation mixing ratio. Means that my water has no more capacity to hold any more water droplets if I happen to be on this line. If when I line up and put my dot on the line, if I'm on that line, I'm at 100%. Everything above the curve is condensation is greater than evaporation. Everything on the line itself is condensation equal to evaporation. And everything below the line has condensation less than evaporation. So I have more evaporation taking place below the line, equal amounts of condensation and evaporation taking place on the line, and condensation being greater than evaporation above the line. I know it sounds silly, but it's pretty simple and straightforward when I get into this. So now I'm going to clean up this curve a little bit. And we'll talk a little bit about when I have this information, what am I looking at? So one of the pieces of information that I have is that I know on my little line that I happen to be at 30 degrees Celsius, right? Because this is where I put my, so that's my temperature out. I know the mixing ratio is equal to 12 grams per kilogram. Another piece of information I can find out is what is my dew point temperature. What temperature would I have to cool off to meet my line? Now one of the ways I like to do this is line everything up. So I'm going to hit my line and take it down, and I'm actually going to draw a little box to help me do that. And I can see that the spot that I'm lining up with is right here. So I know that my dew point, dp, dew point, happens to be about 15 degrees Celsius. So if it gets as cold as 15 degrees Celsius, I can actually cool it off and get a water coming out of suspension, or dew on my ground, right? That's what would be taking place in this example. Some other stuff that I can do is figure out relative humidity, and I can also reverse things and find numbers based on relative humidity. And this just takes a little bit of math. So if I know these numbers, I can actually look things up and figure out what my math set is. So, examples of this. I have a little page here that shows me this setup of how I would do my math to find my relative humidity. And that is, I take my actual mixing ratio, which I can see as the number itself, it's my measurement, and I divide it by my saturation mixing ratio, times it by 100, and I get my relative humidity. So for example, if my mixing ratio is 4 grams per kilogram, and I look up my temperature at that given set, so I'm going to go back, and I get 4 grams per kilogram, and we'll say that it's very cold outside today, and so I'm at 4 grams per kilogram, and we'll make the temperature 5 degrees outside, so I'm about here, right, on my line. So I'm about this dot. We'll make it really cold, 5 degrees Celsius, and I go up and I can see that it's about 8 grams per kilogram on my number at that temperature, so I can divide up 8 grams per kilogram as being the line, the red line on the other, and I divide that and I get 0.5. I can times that by 100 because I'm using my equation here, and I'll get a relative humidity of 50% at that given information. I can reverse this. So let's say I knew that it was 50% relative humidity, and I knew that I was at 50% relative humidity, and I knew my temperature outside was, my 5 degrees Celsius. I can then go back to the table and take my 50% relative humidity, my 5 degrees Celsius, so my little dot, and go up to the curve. And I can see that it's 8 grams. And let's say I don't know my 4, I just know my 5, right? My 5 degree temperature and my saturation of 8. So I know that I'm at this mark and I do not know what my set is. I can reverse my equation and I can take relative humidity divided by 100% times that by my saturation mixing ratio, and I would get my answer as my mixing ratio. So this information, this curve and this one equation, can answer for me some different sets of information. One of which being, well, I can look up my saturation mixing ratio, right? Whoops. I can find my mixing ratio. I can figure out my relative humidity, and I can figure out my dew point. So there's a whole lot of information that one equation and reversing that equation and this one curve can give me. And once again, you can use a mixing ratio curve, and then the other curve you will see will be a specific humidity curve. They are similar curves with different units. They're the same information. They're talking about the amount of water present and how much more space can I fit, or how much more water can I fit at any given space. But they're different units. This one, when we're talking mixing ratio, is grams per kilogram. And if I'm talking specific humidity, I'm talking about grams per meter cubed. So just keep in mind your units so that you're writing the correct units. In my equation over here, my units cross cancel so that I get a percentage on there. And when I times this one with my mixing ratio, I times in a unit, so my answer would have been 4 grams per kilogram on my unit. I hope you understand this. If you have any questions, please post in discussions and we can talk about them. I really want to create an understanding on how to do this. It's not complicated math, and anytime I ask you to do math like this, I will always provide for you your units and your equation to help you out. I might give you multiple equations and ask you to figure out which equation to use. So you have to know which equation to use and how to use it properly. But I will never ask you to memorize the equation, because in the real world, you can look up an equation. You just need to know which equation is the right equation to use once you look it up. So that's really the skill here, right? How to use an equation properly and how to determine which equation is the proper equation to use. So, best of luck to you, and I hope this helps.